you should get a notification to say it has been started. Everybody got something? Yeah, okay, then I think Helen, you can start.
Thanks. So I'm Helen Hastie from Heriot-Watt University, and I'm the PI for the UKRI Trustworthy Autonomous Systems, a node on trust. So ours is called Node on Trust. And essentially, we're investigating how trust might manifest between humans and robots, and how we might model this trust, and how systems might be able to adapt to the user and to the task at hand in order to manage trust levels appropriately. So it really is the node about human-robot interaction and trust. So our consortium is Heriot-Watt, Imperial College London and the University of Manchester. And co-Is include Professors Angelo Cangalosi, Yanis Demeris and Tusha Rajendram. And we really are a multidisciplinary bunch, as many of the nodes are. So we have computer science, engineering, machine learning, as well as cognitive science and psychology. And all our contact details are on our website. So when we were writing the proposal, just going to close this one. When we were writing the proposal, we looked at many different definitions of trust, and we came up with these two, a combination of the two. So we are interested in this idea of the willingness to accept one's vulnerability for relying on the behavior of another, and weighing up the risks and benefits. So that was Rousseau, but also irrespective of the ability to monitor or control the other party. So this is important for autonomous systems, because we might not be able to monitor them. So this is particularly important for remote autonomous systems, such as first responders or remote inspection of wind farms. We might not be able to monitor them, so we might not have line of sight. And with the nature of autonomous systems, we may not be able to control them, as they may be fully or partially autonomous. So that's two definitions of trust that we wanted to use going forward. So what about human-robot trust? So trust is an attitude that an agent will perform as expected, and can be relied upon to reach its goal. So trust can be quickly gained. I'm sure some of you are aware of the automation bias phenomenon, where humans generally do tend to trust technology initially. But as we've seen in many studies, trust can quickly be lost. And this tends to happen when trust breaks down when there's an error or mismatch between internal representations. So there's a need for this shared mutual understanding of the task and the world and the environment. And this world environment may be highly dynamic, so we're interested in taking robots out of fixed scenarios such as factories and moving them to close proximity to humans, and this might be in a dynamic, uncontrolled scenario. So it's trust calibration in these kind of situations is going to be very key. And throughout the talk, I'm going to talk about appropriate amounts of trust. So we don't want to blindly trust robots and autonomous systems, but we also don't want to under-trust or distrust them, then they won't fulfill their true potential. So key to our node is the phenomenon of theory of mind. So theory of mind has been intrinsically linked to trust in the literature. So here's a couple of diagrams. So first order theory of mind is I think, she thinks. So the robot is trying to understand the user's intentions, beliefs, etc., desires. And then second order theory of mind is the human thinks, I think, the robot thinks that I think. And this is about being able to manage what the user thinks of the capabilities of the robot, and some people refer to that as mental models. So it's important to manage that, and also how humans view the robots. So theory of mind is essentially the ability to infer others' beliefs, desires, intentions, sometimes called mind reading, because we can't literally read each other's minds, but what we can do is infer what they're thinking from their behavior. So this idea of mistrust can happen when there's a mix-up between how two people understand a situation, and humans tend to resolve this using language and interaction. So the human, could rephrase or say what they really mean, or ask a probing question, and through this interaction, reach like a mutual understanding. So in this node, it's the idea of using interaction to manage trust that we're looking at. So just to drill down into our node objectives or research questions. So there are three main themes in the node. So the first one is modeling. So can we create a cognitive architecture for trust? Can we model various aspects of trust, including theory of mind? And then can we define a set of principles of how trust is acquired over time, and importantly, how we can adapt systems to varying contexts, errors, the changing environment, and all the different users that could encounter the system. And then create adaptive systems that adapt through using methods for transparent interaction. I'll talk a bit more about transparent interaction later. And then finally, we want to create an evaluation framework that we could distribute to the whole programme. So this looks at how we measure trust in subjectively, but also in kind of non-intrusive manners, and how that applies across multiple domains. So our three themes form our three pillars. Everybody in the proposal has one of these kind of architecture, pseudo-architecture diagrams. So this is our three work packages, the core work packages, and I'll talk about each in turn. But on the left, we're looking at a variety of platforms across the three institutes. And then on the right, in terms of the use cases, so we have project partners, and we're looking at use cases with varying proximity to the user. So working far apart, remote autonomous systems, for example, as mentioned before, inspection, or I think that's a picture of a bomb disposal robot there. And then working closer with humans, so cobots, tutors and companions. And then even closer, healthcare rehabilitation. For example, Yanis has experience with autonomous wheelchairs. So that's kind of a synopsis of the whole kind of proposal. So I'll talk about each work package. We're not a year in, but we have a lot of ongoing activity. So I'll talk about ongoing stuff, and I'll just pick a couple of studies that we've completed to talk about in each of the three areas. Okay, so work package 2 is about cognitive modelling. So we're running HRI experiments based on the fundamentals of psychology theory, and then that will inform our cognitive architecture for trust. And then we're also looking at this idea of transparent interaction for trust. So here's some activities that we're working on. We've just completed a study where we're looking at comparing two robots, one that has theory of mind and one that doesn't, and which ones do you trust and what happens when you make a mistake. And importantly, how does the individual's propensity to trust? So individuals are all different. They come to the task with a different background, different experience. So how does an individual's propensity to trust affect their judgments, and also their general attitude to robots? So we've just completed that study, and we're working on the results, and we'll share that when it comes out. And then we're working on this idea of cognitive architecture of trust. So this will be based on Bayesian networks for theory of mind. That's been worked by Angelo Cangelosi. And we want to combine these Bayesian approaches for theory models of theory of mind with simulation-based theory of mind models, which is work done by Yanis Demeris. So blending top-down and bottom-up approaches. So that's what we're working on. Going to start working on that soon. Okay, then going back to the propensity to trust, we're working with King's College London, University of Edinburgh and Swansea on forming a new questionnaire. There have been a couple of attempts to try and do this in the past, but we believe they're slightly lacking. So we're using a Delphi method, so getting experts to select questionnaire items iteratively to create this new propensity to trust questionnaire, and we'll share that with the TAS program as well. And then we're exploring dialogue and transparent interaction strategies to manage trust, and looking at also adapting to personality and this idea of propensity to trust. And we're looking at natural language explanations, both for machine learning algorithms and autonomous systems. So in case you're not aware, there's a IEEE standard on transparency for autonomous systems, and I brought this up because we've just published a paper on this. So Alan Winfield is leading that. We have quite a large working group on this. So the standard should be coming out soon, although I've been working on it for about 3 years. And the standard is all about defining transparency in terms of measurable, testable properties. And so the paper gives an overview of 5 stakeholder groups that we've defined in the standard, and then presents normative definitions of levels of transparency for each of the stakeholders, and provides working examples of those, how the standard could be implemented. So here's a table for the user, end user stakeholder group. And you can see it goes from 0 to 5. One is like a user manual, and then 3 and 4 are about providing explanations of behaviour, and more complex, like what would you do if, and why didn't you do that? So counterfactuals. So it's this idea of explanations that I'll talk about next, because we've done some work on this, explanations as transparent interaction. So this is a study that we did through video, because we're in a pandemic and we can't do human-robot interaction experiments. So we had participants watch video vignettes, and it was basically an actor interacting with a robot, and the robot was doing COVID triage. So the robot would ask questions and then diagnose the patient and say, come in the hospital or go home, you're fine. And there were 2 types of interactions we looked at. So high transparency, where the robot provided an explanation behind its diagnosis, and low transparency, where it just gave the diagnosis. And then we instilled an error in quite an obvious area in the robot diagnosis halfway through the interaction. So the participants rated the interaction in terms of how likely they would request a second opinion. So this is trying to capture the behaviour, and it's a third-party observation of a human-robot interaction. Kind of trying to capture the behavioural aspects of trust. And then we got them to rate the interaction on the GM trust scale. So our findings were that there was generally a significantly higher level of trust where transparent interaction was present. When it was behaving appropriately, it was significant. And then participants were more likely to make better decisions, so ask for a second opinion and were appropriate. So they were more likely to make better decisions if transparency was high. But we didn't find any significant difference in participants' trust between the low and transparent interaction when the robot made an error. And we think that may be because the error might have been a bit too obvious. So that's kind of an example of some of the human-robot interaction experiments that we're running. Mostly online, but hopefully in person soon. So this is some prior work. So going back to the idea of explanations for autonomous systems. So this is work was actually done previously on the Orca Hub, but I thought I'd mention it here because we are building on this. So for autonomous, this is for remote autonomous systems. So we've worked with underwater and also ground vehicles. So the idea is explanations can increase situation awareness, or we've shown that in a paper, transparency, clarity of mental models. So help maintain the kind of the appropriate amount of trust for these robots that are remote. So I'll just play this very short video, and this is a personal assistant called Miriam who is giving updates on an underwater vehicle. Don't worry too much about the interface; it's a little bit complicated, but you can hear the verbal explanations. Hope the sound works.
What is the battery level of vehicle number 2?
The vehicle is reporting the battery level of 81%.
Why is vehicle 2 spiraling up?
Vehicle 2 is doing a GPS fix, medium confidence.
Why is it doing a GPS fix?
Vehicle 2 is doing a GPS fix at the start of Survey 0 to improve the quality of the data gathered, medium confidence.
Why is it not doing target 0?
Vehicle 2 cannot complete target 0 because there is an exclusion zone overlap. High confidence.
Okay, so this gives you an idea of how we could provide explanations through natural language of behaviour and why it's doing certain things, but also why it's not doing certain aspects, so that the user can build up a good mental model of the system. And so the study that we did was looking at how we present these explanations. How many reasons we should give and what the details were. So for our expert participants, explanations that gave all sorts of reasons, all the reasons possible, but had really low, so had a very few number of details provided with those reasons. So basically, the expert could fill in the gaps, but wanted to know all the possible reasons. Okay, and then the second one, I would actually work with RAM, and this was a prototype that we created for ground robots. You can see this is just a GIF going around an energy platform. So using supervised learning, the robot was able to inspect the platform autonomously, but simultaneously provide explanations of behavior. So you can just about see the text there, you know, seeing what the objects are doing, what the behavior is, and giving things like a different mission status. Okay. So we talked about transparent interaction, we've talked about giving explanations. What else can we do to help manage this, you know, and manage the level of trust in the human robot interaction? So one of these methods is social signals. So social signals and trust, there's been a few studies in the literature. So predicting trustworthy behavior is connected to non-verbal cues. So, for example, leaning forward, head nods, smiling agents perceive more trustworthy. Participants are more willing to follow advice. Empathic agent, more likely to be persuaded if the agent uses non-verbal cues. So there's quite a few studies in the literature that are looking at social signals and trust, and we're also going to be looking at that. So this is one study that we did pre-pandemic. So we had a human interacting with a robot. There's also the system that we used was linked, was based on Orca. So that's why we were able to do this before the pandemic. And then we've been analysing the data since. So with this, we looked at a fur hat robot. I'm not sure if you've seen it. It looks a bit funny in pictures, but it's basically a 3D projected, 3D back projected robot that's basically just the head up. And what we're trying to do in these experiments is try and emulate high stakes, so that the subject has this idea of vulnerability, going back to the initial definition. So we used a fur hat and we compared it with a smart speaker, which is not social, obviously, and the social cues of the robots were mutual shared gaze and other expressions via this back projection. Okay, so here's a little interaction that I'll play, and you can kind of see at the end the reaction to the robot from the user that you obviously wouldn't get in the smart speaker.
Hi, my name is Fred and I'm your emergency assistant. Emergency alarm went off in North Tower Christmas trees. We have 4 minutes and 11 seconds to avoid evacuation. Do you want to make a PA announcement to evacuate the area?
Yes.
Okay, action performed. What type of robot do you want to use to perform the inspection?
Drone.
Okay, sorry, can you tell me which robot do you mean?
A drone.
Let me check that for you. Quadcopter 1 is available.
Good. Okay, send it.
Sending the robot to the designated area.
Okay, so that there you can just see an example of some of this social interaction in a kind of a high stakes emergency response scenario. So in this scenario, some initial findings were that general preference for the robot, and more trust was expressed towards the robot when contrasting robot and smart speaker. And we also saw higher task engagement and faster decision making with the robot. So in a follow-on study, we're looking at, not in this scenario, in another scenario, how robot personality, if we vary that, how that might affect the level of trust in the user. So we've done that study, and again, we're just looking at the results now. Okay, so that's work package 2. Work package 3 is all about adapting. So this is led by Yanis Demiris, this work package, and we're looking at personalised models of trust, so personalising to the user, because they're all different, and maintaining and transferring trust to new tasks. So what happens when you move to a new task, slightly different task, use case, and then how do we repair trust following failures? So this is very much ongoing work, but Yanis is basically going to look at algorithms that can detect patterns between robots and humans to create and populate these personalized models of trust, and then estimate how what needs to change when the robot, the task, or the environment changes. So if you have a robot, so here we have got a Yumi robot. How does that work when we can, models of personalized models? How does it need to be adapted if we suddenly change the robot, the task, and the different user groups? And then what effective strategies are there for repairing failure? So he's looking at personal assistance, so personal mobility, smart wheelchairs, and handover of autonomy. So work package 4 is about evaluation of trustworthy systems. So if we come up with these methods, how do we know that they are valid and are really capturing levels of trust? Because it's very difficult even to get the ground truth of trust, because it is such a subjective concept. So in this work package, we've done some user requirements gathering with our project partners, but importantly, we're looking at creating an evaluation framework for running experiments for measuring trust, and along with an experimental protocol, and we'll share that with the program. And then we're also looking at seeing if we can automatically detect trust in an unobtrusive manner, and one of those is with language, and I'll talk about that. Okay, so here are some ongoing activities. So in lockdown, we decided to do a meta-analysis, and then all these meta-analyses started coming out in the literature. So I think that was a activity that quite a few people thought we could do in lockdown. So, but our meta-analysis is about HRI, but we're focusing on the different tasks and contexts of studies, and that's in collaboration with Swansea University as well. And then I talked a bit about the automatic trust detection, and I'll mention a study there. And then this evaluation framework, we're running some experiments where we're comparing trust scales, possibly creating a new subjective trust questionnaire, and how we can evaluate our explanations. How do we know we're generating good explanations? Okay, so trust and language. So looking in the literature, it's a little bit tricky because there's lots of work on, fake news detection, deception, this type of thing, but that's not really kind of the area that we want to go into. But there are some interesting studies. So one showed higher linguistic mimicry when presented, when high linguistic mimicry for high trusting pairs of participants versus low trusting pairs. So mimicry is similar to linguistic priming. And if we're looking at, deception and lying, fewer self-references, people telling lies, and fake news, there's lots of studies on that. An example of that is more first person, second person pronouns, and less reliable text, and this type of stuff. So we were looking more at kind of around the task success. So if human robots are collaborating, how do they negotiate, and how can the robot, persuade the user so that we can reach a goal? So that's kind of where we were looking at. So we did a study on linguistic indicators of negotiation success and persuasion success, and these were already data sets that already been completed and were quite richly annotated. So we did a short study that's coming up in SEMDIAL. So the goal was to identify linguistic indicators of trustworthy and successful interactions, using data-driven methods also to identify the outcome of the dialogue, if it was successful or not. So we used linear regression models, which are transparent because we were interested in understanding the linguistic indicators, but we also looked at more recent neural models that are more opaque, but more accurate. And the features were traditional linguistic features as well as embedded pre-trained features, and the traditional ones were in the groups of politeness, so gratitude, collaboration, so one of the repeated words, and the LUIC toolkit by Pennebaker, which basically gives you lexical counts of things like pronouns and number of words. Okay, so the results. Politeness cues are important for successful negotiation dialogues. That's nice to hear. But we also saw observed the lengths of utterances were decreasing over time. So people were interacting, having higher numbers of shorter terms. So I think maybe as dialogue is successful, people learn to kind of interact kind of quicker to reach the goal. And then collaborative features are more relevant for predicting persuasion. And as perhaps predicted, deep models were better at predicting, but of course they're less informative. And we got some quite good results in terms of predicting the outcome. And then what we're looking at now is we're looking at gathering data where we're labeling trust not at an interaction level, but at a turn level. And we think this might be challenging, but we definitely think it's worth investigating. Okay. Right, so I did talk about explanations in the beginning of the talk, and but how do we know that we're creating good explanations? So I have a PhD student who's working on this, and this was published in EACL this year. So how do we know explanations are good, and can we find automatic measures for explanations so that we can get feedback and even teach, get them to automatically improve their explanation generation? And this has been a big topic in NLG and conversational AI. So we looked at some of those metrics and see if they mapped over to quality of explanations. So there's a corpus that we collected called the X-band corpus of human-generated explanations, explaining Bayesian networks. I won't go into too many details, but basically it was labeled for NLG type evaluation metrics, so informativeness and clarity, as well as automatic measures that we see frequently in literature, such as blur and rouge and blurt. So all metrics are quite good at capturing the bad examples, but the more recent metrics, such as blurt, seem to be highly sensitive to informativeness and clarity of explanations. So that was very encouraging that we can get an approximation of any output of our explanation systems using these metrics that are being more adopted in the field. Okay, and my last slide is just a study that we're doing at the moment. So this is the PhD student. So again, we're taking the videos that we took in the lab and running an online study. But this way we've got the research goals, so we're looking at these trust questionnaires. So if you've looked in the literature, there's lots of different there's Schaefer, there's MDMT by Ullman and Mal, there's GIAN, and then you see in the literature people just stick in a trust question. So how much do you trust the robot? And that's particularly frowned upon, but we wanted to explore what are the differences in all these different questionnaires. So we started off looking at MDMT and GIAN and comparing this single kind of trust questionnaire. So we got users to rate the same video. We'll just give them quite a long list of questions, and then we're currently comparing them. We're looking at not just the outcome of the scores, but also the effect size. And then future work will be looking at whether these subjective questionnaires with task dependency is important for the effectiveness of these various questionnaires. Okay, so just to summarise, so in the node we're looking at modelling cognitive trust, including phenomena such as theory of mind. using a multidisciplinary approach. It's key to know that everyone is different and every task is different, so we need to adapt to this. And then how can we evaluate our methods, measure trust and predict it automatically? So in future, we're hoping at the end of the year to run some experiments with our industry partners on a realistic use case. So these are our industry project partners. And that's all I have for today. Thank you very much for having me.